Okay, now we're going to go over our first chemistry conversion. I kind of alluded to it earlier in a podcast. Now we're going to do our first one. Now don't think of this as anything different than a unit conversion we've done before in chapter 1. You know, going from a liter to a milliliter or an inch to a centimeter. I mean, this is just going this is a chemistry conversion. Okay? So, one thing we've learned, let's write down the conversions we know, actually. Let's do that. That'd be the first thing to do. We know, if I come over here, that one atom, hold on, you can't see that one very well. Try this one. Yeah. One atom, or no, not one atom, 1 mole equals to 6.022 times 10 to the 23rd, and we're going to call this atoms, or sometimes we just call it a molecule, depending if we're looking at a molecule or just one atom. Because we know that 1 mole is that many atoms, okay? But remember, we're lazy. We don't want to keep saying this number, so we just call it a mole. The other one we know is that the weight of something, so we'll say weight in grams, like from the periodic table, equals to 1 mole. Okay, remember, 1 mole of something, if we weigh out a mole, we can get the weight in grams. You know, like, for example, carbon is 12 grams per 1 mole, so that tells us it weighs 12 grams per 1 mole. So we'd have to look up this number each time. So let's look up an example. It says, how many copper atoms are in 2.45 moles of copper? So we have 2.45 moles. Make sure it doesn't look like 245. 2.45 moles, and we want to know how many atoms, okay? Well, we just have our conversions here. Remember, these are the exact same as any other conversion we've done. Well, look here, we have a conversion between mole and atoms right here. 1 mole is 6.022 times 10 to the 23rd atoms. Okay, what number am I going to put down here? Right, I have a mole here. I want to cancel it out. So I'm going to look at the conversion and I'm going to put 1 there. I know 1 mole is 6.022 times 10 to the 23rd atoms. Okay, and remember, I put the 1 down here so it could cancel out right there. So now, this cancels out, and this cancels out, so then I just have 2.45 multiplied by 6.022 times 10 to the 23rd. And let me see if I have the answer on here. Yes, I do. 1.48 times 10 to the 24 atoms. 1.48. Okay, write that down. I think it was 1.48 times 10 to the 23rd atoms. Let me check that to make sure. 1.2 to the 24th. Okay, so let me nope, the 24th atoms. Okay, so that tells us if I have 2.45 moles of, what was I looking at? Copper. Okay, if I have 2.45 moles of copper, that means I have 1.48 times 10 to the 24 atoms of that. Remember, atoms are your protons and neutrons in the nucleus with the electrons around them. So it tells you how many atoms, I mean, think about all those individually, and 2.45 moles of that, okay? And that's a lot. That's a huge number. There's a lot of atoms in any mole. Look, 1 mole has 6.022 times 10 to the 23rd. That's how many are in 1 mole of it. So when we had 2.45 moles of it, it's 2.5 times bigger. Okay, let's look at another problem. How many moles are in 0.0265 grams of carbon pencil lead? Let me see if it'll let me copy and paste this. I've never tried this before. Hopefully it doesn't just explode my computer or want to think forever. Okay, it just didn't like it. That's fine. Okay, so let me just go away. It keeps popping up. Okay, I have 0.0265. Okay, right here. Oops, here, here. Okay. 0.0265 grams. And I think I wanted to know, was it moles? Let's see. How many moles? Yes. So look, I have a conversion right here that uses a gram and a mole. Okay? So I need to look at the weight. And what am I looking at? Carbon. Okay? So let's look up how much carbon weighs. Carbon weighs, looking right here, 12.01. And I'm just going to put 12. Okay? So I know, let me write this down here. Carbon weighs 12 grams of carbon. That's how much it weighs per 1 mole of carbon. Because that's the conversion. When I get the weight, that's always how much 1 mole weighs. So now I want to convert 2 moles. So what number do I put down here? We'll see, I have a gram right here, so I need to put grams right here. What number goes with grams? 12. So I'm going to have 12 grams of carbon, and then that equals to 1 mole of carbon. Okay? Gram cancels. Grams cancel. So I'm going to have 0.0265 divided by 12. And I already did this. 2.21 times 10 to the negative 3. Okay? That equals to 2.21 times 10 to the negative 3 moles. Okay, so let's look at this. Okay, so 1 mole of this weighs 12 grams. Okay, but we don't have 12 grams. We only have 0.0265. Okay, we have a very small amount of carbon. So that's why we have a very small amount of moles. Okay, so let's do one more. And let's just do a long one. Let's go further. Let's convert. Let's do this one here, except let's go to atoms. New. Okay, so if we have, let's do the same thing, 0.0265 grams, and we want to go to atoms. And this is of carbon. Let's just do the same problem pretty much. So let's write down our conversions we know. These are the only 2 conversions we know of chemistry so far. So in a way, it's almost easier than all the other conversions we've done because we only have 2 we have to know and not, 400 million. Okay, so we know that 1 mole is how many atoms? Avogadro's number, 6.022. 0.022 times 10 to the 23rd atoms. Okay, and then we also know the weight of carbon. In this case, carbon, remember on the periodic table, weighs 12. So we know 12 grams equals to 1 mole. Oops, mole of carbon. So again, if we weighed out 6.02 times 10 to the 23rd atoms, if we weighed that out, it would equal to 12 grams. Okay, and that's 1 mole. So here's the common denominator right here, is this mole. Do you see how it brings everything together? 1 mole equals to this, and 1 mole also equals to that. Okay, so now let's do our conversion. And we start with the number they gave us in the problem. You always start with that number. So we have these conversions, and those are only there to help you go further in the problem. It doesn't help you get started. You always start with the number given. Okay, so we have 0.0265 grams Okay, so we have 0.0265 grams of carbon from this number here. Okay, now can I go directly from grams to atoms? Now we have two conversions. This one goes from grams to moles, and this one goes from moles to atoms. Is there one that goes directly from grams to atoms? No, so we're going to have to do this one step at a time. So first we're going to use this conversion here. Why did I choose that one? Because it has grams in it. Okay? Now I know I have 12 grams of carbon per 1 mole of carbon. Again, why did I put grams at the bottom? Because I have grams right here and I want to cancel it out. Okay, now let's go to our next one. I want to go to atoms now. I'm going to go from mole to atoms. So I'm going to put 1 mole of carbon equals to 6.022 times 10 to the 23rd atoms. Atoms. Okay, now again I put 1 mole here, 1 mole here to cancel out. Okay, and that all came from, right in here. Now let's see what I have. I'm going to have 0.0265 multiplied by 6022 times 10 to the 23rd. I'm getting my calculator out right now. So I have 0.0265 multiplied by 6.022 times 10 to the 23rd, and I get 1.59583 times 10 to the 22. Okay, now I'm going to divide that number by 12 because it's down here. So divide by 12. Okay, so I get approximately, let's see, since we use 3 significant figures here, I will use 3 significant figures on my answer. So I get 1.33 times 10 to the 21 atoms. Okay? And so that tells me if I weighed out 0.0265 grams of carbon, that has 1.33 times 10 to the 21 atoms in it. That's a ton of atoms. Okay? And that's the longest the conversion can go so far, from a gram to an atom. And I could go backwards. I could give you atoms and go to grams, but it wouldn't really be any different than what we just did here. So practice this and let me know if you have any trouble with it.